back to an area problem here. Hopefully you've had a chance to look at the other two examples. We're dealing with a situation where we have two curves. They're both above the x-axis, but that's not really what's important here. Again, we're getting these and we take the top equation and we subtract from it the bottom equation. Now, we need to know where y equals 4 minus x squared and y equals x squared intersect each other. So once again, we set them equal to each other. So we have 4 minus x squared equals x squared. So we get that 2x squared minus 4 equals 0. So 2 times x squared minus 2 equals 0. So x is going to equal to plus or minus the square root of 2. So we know that this is the negative square root of 2, and this is the positive square root of 2. Now, let's just say, for example, that we didn't know which one of these was on top at this particular time, which one was on the bottom. Well, to figure out which one is on top and which one's on the bottom, one thing that you can do is you can pick a number that would fall in that domain between negative 2 and negative square root of 2 and positive square root of 2 and plug them in. So we could figure out zeros in there. So we could say, okay, 4 minus 0 is 4. And here it's just 0. So we know that this equation would be on top of this equation. So my integral is going to be from the negative square root of 2 to the positive square root of 2 of the top equation 4 minus x squared and then minus the bottom equation minus x squared dx. All right, now if y'all notice also I'm wearing my glasses today because they're not fogging up, and read it still doesn't make you look any better. But anyway, let's go from here. We've got two even functions, and because both of these functions are even, I know that my area from here to here, negative square root to 0, is the same as my area from 0 to the square root of 2. And if you think about it, when I do this integral, plugging in these two numbers right here is going to get a little ugly. So I can change this to being 2 times the integral from 0 to the square root of 2 of 4 minus 2x squared dx. And that makes my arithmetic work out a whole lot neater. Again, you have to make sure that you know that the area on both sides of that region are the same. So we can go with this. So it's 2 times, all right, this is going to be 4x minus 2x cubed over 3. Again, going from 0 to the square root of 2. So all we're really left with is just plugging in the square root of 2. So we get 2 times 4 square roots of 2 minus, all right, the square root of 2 cubed would be 2 square roots of 2. So we get 4 square roots of 2 over 3. And then, of course, it would be minus 0, so we don't have to write that out. So we end up with, all right, this would be 2 times 12 square roots of 2 over 3 minus 4 square roots of 2 over 3. So this would be 8 square roots of 2 over 3 times 2 would be 16 square roots of 2 over 3. That would yield us the area here. Now, I'm going to put up a couple of more videos dealing with some sample area problems. Watch as many as you think you need to. And what I'm going to have to do is I left my worksheet packet at school, so I'm going to scan you a list of problems for you to upload and work on. So also looking at possibly Friday doing a question and answering session on these area type problems. The next example problem we're going to look at is going to be a problem where we're going to want to solve the area out using horizontal cross sections instead of these vertical cross sections. I'm going to go ahead and draw you the drawing of what's going to happen so that I don't have to get into that on the next video. But we're going to have a It's not a function. We're going to have a sideways parabola though, and it's going to intersect with a line. And as you'll see, if you do vertical cross sections, you've got one region that's going to look like this. And then what happens in the second portion is you're going to have